so you should prepare. After there is new file dialog.
It's for Thursday.
ModTalk, this is what?
It's for Thursday, not Thursday.
Why? I just read that.
It's behind the parentheses.
It's a list, you know, so how can I guess that this is like Tuesday, okay, you know, okay. Okay, sorry, so there is ModTalk, Tuesday, reintroduction of...
time. So, if you have not guessed yet, I'm a researcher, okay? And there is this service called Zenodo, which allows you to publish artifacts, and they get their DOI, so you can cite them and so on, and this is a nice thing to publish your things which are not papers. And what I want to say that there is ESUG, I don't know what community there, so if you're using Zenodo or if you're submitting something there, you can also like check, like put this into ESUG community, so the community can benefit from your artifacts. And that's it. I'm kind of self-proclaimed guy who filters stuff there, so no one will just submit their survey of tea shops in New Orleans, because I guess there was already something like that. But yeah, that's it, just to let you know.
So we've got 6 minutes distributed over the next 5 points.
Peter.
Peter.
ModTalk close. So I have 8 minutes. So first thing, yeah?
9 minutes now.
Display. Yeah, wait. I have to mirror them. That's this configuration. Okay. Can you see? Yeah, perfect. So, first question. Does anybody know this guy? Yes. So, the guys that work on Faro, we call this guy the monkey. This is the guy that is taking care about the integration process. So, every time that there is an issue in the issue tracker, and we post a fix in there, so the monkey takes the code from the repository where we put the fixes. He will try to integrate the fix, he will test, and he will tell you something like monkey's checking, fix reviewed by the monkey, or validation failed, and so on. The thing is that if you tried ever to run the whole suite of Faro tests, it will take around 15 minutes. And no, Yuri was telling me this morning, yeah, Yuri, that running the lint rules for the entire Faro image, it takes around half an hour. So one of my next crusades is to actually make integration easier for everybody. Everybody should be able to run the same thing that is validated in the server side for the integration in their machines before actually publishing any commit. So one of the things that I was working on to make this better is that I want to parallelize the running of tests and lint rules. So I revived a project that we started a couple of years ago with Santiago, a friend of ours, that is Taski. So, I will go just for a demo. First thing that happens, when you're using a Faro, something that happens if I don't have the thing to actually take the, I cannot type and open at the same time. Not enough hands. Okay. So, if hello. Okay. So, if I execute something like this, seconds, wait, one, inform, test, and I execute this, what will happen? So, first thing is that there is a text that will be shown in the screen, but it will be appear 1 second after actually execute this. Yeah? So, okay, it's there. it's really small because it is not sensitive to the settings, but okay. But the thing is, the other thing important to this is, I don't know if you did notice, but actually, when I execute this, the whole IDE freezes. Yeah? So that is because, okay, we can say this is executing in the UI thread. That's not good. The other thing that is not good, so we can say fork, but then we lose control on this. This is a new process that will run, so this is really low level. So for those that use fork, I don't recommend it unless you actually know what you are doing, because it's a really low level way to create a thread actually. So okay, so Taski is about controlling a bit how we execute concurrent tasks. So for example, I have a nice schedule message. Okay, in this schedule message, it behaves so far as a fork, but actually it's behind executing the task in a worker pool. So we have a kind of worker thread with many threads that run in parallel. We are scheduling the task in that worker pool. And like that we can also, for example, get a future on that. So for example, if I say factorial, and then I inspect this guy, the guy will finish and will tell me that it was a success, and I can get the result back. Okay. So I have some other little snippets prepared. So besides scheduling futures, so we have scheduling example there. We have also actually several task runners. So the idea that this schedule is just a syntax sugar for scheduling a task in a given task runner. A task runner can be, for example, a worker pool or a worker thread, or it can be a runner that actually creates a new process every time that you schedule a task, or it can be actually a runner that executes the task in the same process where you are executing your task. So this one actually will will be exactly the same as just executing the code in the workspace. It will block the execution. This one will behave just as a fork, and we have pools here. Here we have, for example, a worker where we can actually schedule several tasks, and he will execute first the first one, the second one. Even if the first one has a 1 second wait and the second one is immediate, so he will execute sequentially. It's a worker process. So okay. So important thing, we have documentation. If you want to know about it, you can go to. I will paste it in here because it's bigger. So if you go to GitHub, yeah, we're using GitHub. We are using Iceberg for this. So we are one of the beta testers of Iceberg. You go to sbragagnolo, Taskit, and there you will see the documentation. The current, actually, we will be releasing a stable version in tomorrow, I expect, or the day after. But here you have already some documentation about scheduling tasks, how to create tasks. You can create your own task. Actually, it's extensible. You can actually work with futures. Futures have callbacks. You have different task runners. You can have exception handlers in the task runners. You have task that timeout. Also, you have future combinators. So if you have several futures, you can combine them in a functional way. So you can say a future, collect, blah blah blah. So if you know what I'm talking about, that's cool. And then there are some other things. I don't know. We have services. I don't know. So you may go there and just read some. The nice thing is that yesterday I was talking with Nuri, and I implemented in 10 minutes an active object for Nuri. So an active object is an object that will schedule all messages that we send to him into a queue, and he will execute the messages inside in the order that we send them. It's like an actor, but this one is a 10-minute implementation. So, the idea is that, for example, I create an active object, I create 10 times the message test. Okay, I have time. And then, and this guy is actually in this message test. He will so he will wait a second and then print in the screen. Actually, he will inform the identity hash of the current process. So if we do this, we are scheduling 10 tasks, 10 test messages actually, and they execute in order just 1 second after the other one. The nice thing is that here we don't see there is no task scheduling, there is no finished. Okay. So yeah. So log task.
Who is the next one?
Introduction of Smalltalk. And then Smalltalk 78.
Hey guys, how are we doing today? My name is Josh Friedstrom, and I'm here to talk to you guys about ModTalk. Yay! ModTalk is a new and exciting flavor of Smalltalk, and this is the ModTalk team. The ModTalk project started about 3 years ago. There's been a number of people who've contributed to the team here and there, but these 4 guys here have been sort of the main core of the team consistently over the last 3 years. It started at Northern Michigan University, which is where John Sarkala is an instructor. Some of you guys may know him. He's been around in the Smalltalk community for a number of years, and he has been dreaming of this modular Smalltalk for a long time. And so what is ModTalk? Well, first of all, it takes a number of rapid departures from traditional Smalltalk implementations. For example, there's no image in ModTalk. Source code is stored in files on your local machine. And ModTalk is a compiled Smalltalk. We compile directly to native executables. Right now we support OS X and Linux 64-bit. So why on earth would we want to do any of these things? You guys are like, no image, that sounds crazy. Well, the motivation for modular Smalltalk comes from some papers written by Alan Wierfsbach and some other people working with him. In fact, in 1988 he wrote a paper entitled Modular Smalltalk, and it was about a number of issues that Smalltalk had in production development environments. And one of the big issues that he saw at the time, and I think this is still partly an issue today, is the separation between the development tools and the program being developed. And there are a number of reasons why that can be problematic, but just the whole idea of when does your program stop and when does the tools that you're using to develop your program start. And that can be a little bit blurry, especially when it comes to deploying to production hosts. You have to strip out your application, try to pry it from the development environment, but oftentimes they're so tightly integrated and you're so used to developing in your development environment that you take dependencies on things that are in your development environment that are really implementation details of the language, not definitions of the language itself. So that's a big motivation, but there are some other motivations as well. This has been talked about this week, source control. I think I probably don't need to reiterate the talks from earlier, but I think there's a consensus that we want to use Git. We want to use Perforce. We have Monticello and Metacello are great tools, but they're not necessarily industry standards, and it's just another roadblock for people who are new to the Smalltalk community. It's another roadblock for them to overcome when it comes to learning Smalltalk. Again, this is literally, this was just, a presentation was given about this just a few minutes ago about Smalltalk fitting in standard development and deployment pipelines. We have to create entire frameworks just for Smalltalk to fit in traditional deployment pipelines, whereas with ModTalk, it's a lot easier. What about scripting? Has anybody ever needed to do some script on your Linux box and you said, well, I guess I have to go whip out Python, or I guess I have to brush off my Perl skills. Wouldn't it be nice if you could write a script in Smalltalk? How awesome would it be to use a select on like a directory listing? So that would be pretty nice. Scripting would be cool. And I had a conversation earlier with somebody about embedded systems. It's really hard it's not impossible. I mean, there are people who do Smalltalk on robots and other embedded systems. They try to get really small images, but it's not easy to do. You start with an image which has everything that you need and more, and you have to try to strip it down until you get just something that's small enough to fit on an Arduino or something. With ModTalk, these problems are trivial. So ModTalk is a ModTalk program is composed of modules. Modules are the building blocks of a ModTalk program. So what are modules? Well, they're not that hard to understand. You have definitions. Everybody knows class definitions, constant definitions, and there are a couple modules that are sort of encapsulate those definitions, and some of them you're familiar with already, like a package. Packages are just like packages in Pharo that we've all used. Clusters are modules that let you view packages. For example, you could cluster packages that you're working on that day, or you could cluster packages related to a particular feature. That's one way that you can modularize your code around a little bit. And now these modules are a little bit more interesting. We have subsystem modules, which it's a namespace, defines a namespace. All of the classes and constants and all the definitions that are found in that subsystem form a namespace. And then we have program modules. Now, a program module is the declarative specification for a ModTalk program. So you don't have to worry about, this is my starting point in my image, now I have to strip everything out that isn't the program. No, when we compile a ModTalk program, we start with the program definition, and we know it's clearly defined and we know exactly what we're going to get. So module composition is what ModTalk is all about. It's how do we take these modules and put them together into a Smalltalk, a well-defined Smalltalk program. So I think I'm going to show you guys that. That's probably the easiest way to do it. Okay. Here we have a simple program. This is a program specification. Pretty straightforward. We have a couple different syntaxes. One of them is JSON syntax that we like. And this is the source file for the ModTalk program. And we can take this program and we can load it up. And I'll show you that actually. I'm going to do that right now since we're running out of time. This is, so another thing about ModTalk, all of our IDE, our compiler, our development tools are all written in Pharo. At the moment, Pharo has been our bootstrapping environment with the plan to eventually port ModTalk to itself. So let me open, this is a project browser. I'm going to go ahead and open up the simple program right here. Or not. Let's open this one. Okay. If you have any questions, I'll be here. Just let me know. We can keep this conversation going.
Next will be Smalltalk 78.
Okay, hello. My name is Martin Fettmann. I come from Hamburg in Germany, and I'm working for two companies, which is not that difficult. It is 1 billion, 1 euro to one boss. The first company is Infratestima. We do election result presentation for the first German television broadcaster, ARD, and third channels. And in progress is now developing CARTI software for the company called GAS. Introduction of Smalltalk because we were a Smalltalk company. We went out of Smalltalk business 2003. We used VisualWorks, and therefore we had experiences with object-oriented databases and GUI modeling tools like Argos. All these stuff is gone. It's never far away. And since then, I'm the only Smalltalk in the company, and I still looked for a place where we could use Smalltalk technology again. And due to customer demand, we were asked to export our election result into the internet. And actually, the results, the project results are not that interesting. I just wanted to show how much work I had to do to reintroduce the technology again in the company. This is the application we had to write for the SWR broadcaster in Baden-Württemberg. These are the official results of the election in March. This is a browser application written in jQuery for mobile and desktop browsers. And this one is requesting data from remote JSON remote server where fixed JSON structures are located, and the whole data are produced by Gemstone. Therefore, we introduced Smalltalk by using Gemstone. The next application, the other company, is now a management product, which is a CARTI. A CARTI software is one of these not so nice software. The people are calling you and they ask you if you want to answer a question. This is not the good project I normally mention because nobody likes this. But this is the project. This application is written in a special JavaScript library from Zenshare. It's called XGS, and this one is directly communicating with Gemstone. And this is in development now. This is our normal application structure. We have the end application here. This was in jQuery. We had Akamai caching because at these events we have hundreds of thousands of hits in the evening just to get the results of the election results. And as you can see, we have a renderer server written in Unity 3D in the internet to produce the pictures, the result pictures. We have management software for the maintainers. We have Python script, non-GUI, GUI stuff, Apache. You see lots of different languages used here, and all they are communicating with Gemstone S to maintain the results and to export the results for the user. And the other applications, more or less, also built. And when I tried to implement, I saw the slide yesterday, and when I tried to reintegrate Smalltalk in our company, I had to go this way. No other way. We have other developers and they're not willing. I can understand them. They're not willing to use Smalltalk. They are Java developers, they are C# developers. They have tremendous tools. They can build wonderful stuff. And now I come with a very strange technology called Gemstone, nobody knows of. And everything I did was this in mind. My colleagues in the company had to work with the system, and I have to support them in their language they use, not I am using. Therefore, I had to build some confidence in the company. I had to always, I mentioned I want to use Gemstone for 20 years and I want to do this now. And my boss said, yes, okay, but we have to build a lot of fallbacks. If Gemstone is failing, nobody knows Gemstone, we have to use some other development. Therefore, we made a decision. We created an API-based development. That means every application triggering data from the database has to go via an API. It is very wise not to be too visible, this technology, to make this, or to hide the technology. And I choose, for example, Python and not Ruby as a scripting language, just because this is more mainstream and it's wonderful. If the other developers ask me, how do I use your API calls? The first time I gave them Smalltalk code, and this was not very productive. And then I choose to support Python, and now they get Python code, and they have no problem with this one. On the other one, I have to prepare the company over more than 2 years just to keep simple technology, not very complicated standards, but stay on simple stuff. We had to think about a programming model. We had to create a code generator for that program. We already had one because we moved 2003 from VisualWorks to C#. I took this code now, made a complete different programming model, client server. We model in this tool the domain classes. We model the API. We define the API definitions. We have a separate API hierarchy classes. And these API classes are only used in the API. That means we have separated domain classes and the API classes. We have written, or I've written generators for Topaz, the server code, of course, C#, Python, and XJS, and VX Smalltalk just for me.
1 minute left.
Okay. Overall, more or less, when doing this stuff, I always have to think for the other languages first. And it is very a good way that I do my own programming stuff, at least the first demo, in the other languages also, and not in Smalltalk. That means I wrote the first GUI just to show that it's usable and how it is usable, and then they accepted more or less the application. But I'm still facing the typically direct question: what is Gemstone as? What is Smalltalk? I have the idea that, or the feeling that the OOBM DS knowledge is vanishing. They all use Java and relational databases. We have also talked about lots of license restrictions due to Gemstone. We have license fee discussions, and the typical question: what happens if you're ill or you're dead? These are the typical questions I have to face. Thanks.
Next we have a quick 5.1. The next presenter will be Tim Felgentrep, Squeak 5.1 and Ito 6. And now we have Smalltalk 78.
Hello, my name is Pat Freudenberg. About 2 years ago I already presented Smalltalk 78, but since a lot of you were not there, I'm going to present it again. Also, this year, one of the major, I would say, grandfathers of Smalltalk died, Seymour Papert. LMK was inspired by his work with children and Logo and computers to create a programming language that can be used by children. And he named it Smalltalk, and he made it to look like a lot like the English language, and that's what we are still here to use nowadays. So I thought of a way to sneak that into some of the presentation, and so this is one one image of CMERT back in the day, and let me see if I can mount that here maybe. So Smalltalk originally was using a black and white bitmap display. It was outrageous at the time to waste one full bit for each pixel. The whole machine it was running on had 128K words, I think, 16-bit words. But the display memory alone took up half of that space. So you can still do graphics with that. So in the Smalltalk 78 system we have a little dithering algorithm. This one was not in the image we found, but the technology was there. So that's a Floyd-Steinberg error diffusion dithering that you can do there. So this is running in the lively kernel. Maybe I should go to full screen, it's a little bit better. Full screen. Lively kernel, if you don't know, it's a Smalltalk inspired development environment for JavaScript. So everything is live and you can go in there. And this is just a little VM I developed together with Dan Ingalls. Does anybody see my mouse cursor anywhere? There, okay. Which is a little debugging interface, so you can stop running it at any time. You can see the bytecodes. So bytecodes were invented for this little Smalltalk 78 machine. Smalltalk had many releases. Basically every 2 years they started over and invented the system new, but they actually used the objects that were in main memory. They wrote them out using a system tracer, it was called. And so 78, the 78 version of Smalltalk is the same as Smalltalk 76, which is the major version before Smalltalk 80, which we all know. And this was the version that was used on a small note-taker computer. That was a little machine that had 3 little Intel 8086 chips, brand new at the time. One was used for bitblit, one was used for the interpreter, and one, I think, for the Ethernet port. And so then Ingalls ported Smalltalk 76 to there, and lazy as he was, he didn't want to port all the assembly code that did the graphics drawing to Intel. So what he came up with is he only ported bitblit and rewrote all the graphics operations in terms of bitblit, so that he could do it in Smalltalk. That's pretty cool. And I cannot really tell you how we got this image, but we got it. It's an original image from 1978. This one is a little bit modified because we used it actually for some demos. Alan was giving a demo, which is on YouTube. It's over here. YouTube. If you Google for Alan's case, tribute to Ted Nelson at Intertwingle Fest. That's a talk he was giving there, and he's using that system. How many, like 3 minutes or so? So I cannot really give you that image, but you could recreate the same things just using this. So it's, if you want to know the URL, just livelylab.org, user-bit, Smalltalk 78. If you Google for Smalltalk 78 and JavaScript, you will find this. It's also interesting to look at how this works internally, because there were no block contexts yet. The syntax is very interesting in a way. So you had to declare variables. I like this. Maybe I should make this larger. Okay, is that okay? So you had I, and then you had a for with a little open colon that's different from the regular colon. So for I from 1 to 10 do, and then you have another block-like thing. It was called the remote code, and you could say I becomes I plus 1, and then in the end is I, and if you print this, it should be 11, yeah. Oh, that was stupid. Let me maybe introduce another variable a. I wanted to sum all the variables from a0 for a plus I, and then a, and that is 55. Okay, so, huh? Yeah. So this is really cool in a way because I could have used square brackets here. It's the same thing. So this is not a block. It's really just, this is a keyword that makes the next expression, it's like quoting it, right? So it's compiled into remote code, just like this reference to I, which is a read of an I, and then there's this, so this is compiled into a bytecode that's reading, returning the I, but then the primitive that sets the I value just gets the bytecode, looks which index it's actually writing, and pokes a value into the current context at that place. It's crazy, it's elegant, it's cool, and I just can invite you to play with these things here. And these are projects that Alan has made, Alan K, just to show some, yeah, in that demo, it's there. If you see the demo, and yeah, just come and I can give you a demo using the actual image, but I cannot give you the image for reasons. Okay.
Next will be caffeine, please. Preparing. And now what we are seeing.
So I'm not going to use very long. Just basically two announcements. The first is that the Squeak release manager for version 5.1 instructed Fabio about, I guess, 90 minutes ago or maybe 2 hours ago to release version 5.1 of Squeak. So if you go to the website now and click the download button, you do get a new, very fresh image with lots of new fancy features. And the download button is currently... I always like taking credit for other people's work. The download button gives you a 32-bit VM right now. We did this just for backwards compatibility for people who don't really follow the development if they have old images lying around and they just click download, they want to load up those old images. But if you go to the actual downloads page, you can also get 64-bit bundles. And I'm going to just quickly go into, I've already downloaded one of the bundles, just to show you what awaits you. As like any good professional IDE, we now have a welcome wizard that welcomes you to Squeak. You can skip it if you don't want it. I'm just going to go through there because it gives you kind of like walks you through some of the settings. These windows here are live, so you can play with them while you try out the different settings, try out the themes. I personally prefer this theme because this is what I set my terminal to as well, and it's nice that I finally can set Squeak to be very low contrast as well. But if you like what the community prefers, you might go with Community Dark. You can walk through some of the interesting settings, kind of I like my windows around it, and while dragging with the window visible is nice, it does feel kind of sluggish sometimes, so I always switch fast drag back on. Anyhow, then we also have a very nice, slow entrance into the image after you're done. Then the welcome workspace now has gives you some links into the image directly. So when you're reading it, you can click the links and it will open various tools on on different parts of the image that you can explore. It talks about graphical tangible objects, and if you click that, you actually get one of those tangible objects, and then you kind of have to shake it off. The professional term for getting rid of them is shaking it off. We also have, and yeah, if you're interested in what's changed, Marcel has been very diligent and prepared release notes with lots of links in them. So for anything that changed since the last version of Squeak, if you're interested, just click on the links and it will take you to the code and you can explore. And then one other thing that has finally come back to Squeak is we finally now have different languages. Yes, I can finally set my image to be in German again, so you can't use it. And it's loading, and now I can open my Werkzeugkiste. Einstellungsverwaltung. Yes, and there's lots of other languages. What?
You still have a browser.
Well, yes. Unfortunately, we didn't find enough people to sit down and type up all the translations. I did run some of the translation files just through Google Translate. So you might stumble upon some very interesting translations. For the Germans in here, Squeak was translated by Quietschen. So
yeah, use the Bing translator. It's far better for this.
Okay, I will next time. And yes, you can set it to Filipino or French or whichever you want, whatever suits you. Does French actually work? Yes, it works. Utils. Navigator. Yes. Okay. Based on this new release, we're also preparing, not ready yet, an updated version of the last eToys release from 2004, I think, or 2007. When was that? It's pretty old.
Not that old.
Okay,
it's like 11 or 12 or something.
So, so that last eToys release, that still ran on the old interpreter VM with no way forward, and it used all the image segments to save all its projects and all its data. So they never really merged it back into Squeak. So we went through the trouble. We started to go through the trouble to get it running again. This is now running on Spur, and as you can see, we have the old project that greets you loaded again into that image, and I can set it up. And of course, the color is wrong because the background color is different now. And now we can see the car moving, and the gallery of projects also works. And the project loading, Bert implemented an image loader for the old image segments, so you can go through the old projects and kind of look at what people did.
And that's image level Smalltalk code?
Yes.
That is. And also Kedama is still working. I wanted to show that real quick.
1 minute left.
Okay. For those people who don't know what Kedama is it was done by, I think it's a PhD thesis by Yoshiki Yoshima. It's a way to script basically lots and lots of pixels simultaneously. Here we have flappy pixels that try to kind of, they always sink down and they try to fly around these trees. The way that works is these trees have this aura here, and the birds see the aura. So each pixel in parallel processes what it sees under it, and when it sees the aura of a tree, it tries to go up and out of the way of the tree. So we can, I can make the aura larger, and then they get out of the way quicker, or if I make it too small, they're all going to fly into the trees eventually. And of course, I can also increase the count of our flappy pixels. If I can, yeah. And I haven't tried this, so we'll see what happens. Where is it? So count 20. Right now we have 20. Let's try to 100. And so right now this is and Kedama, when Yoshiki did it, he did a C extension to enable all this parallel processing. We haven't ported that forward. I was very happy to see that Spur is fast enough to just execute this purely in Smalltalk. All these pixels running, processing in parallel what their surroundings, and it's basically like kind of like CPU level shader programming for kids with tiles. And I think that's really can be really very fun.
No, skip me this time.
Okay. So, Gustavo Santos?
You evil browsers.
It's so fast.
Okay, next will be Christian Heiner with charts in SVG. No, the next one. This Gustavo. Okay. No, here it doesn't say it. Okay, but don't worry. Okay, Gustavo Santos.
So, as I presented yesterday at the Innovation Awards, this is macro recorder. Basically, you can record code transformations that you can apply them automatically to other locations. So, I will present the same case study as yesterday. So, right now you can select as a custom transformation if you already recorded it. And then you have the transformations here on the left and the configuration of the macro on the right. If everything is correct, you just replay the transformations and then it's configured automatically to your case. I didn't replay it. Okay. So, if you are migrating code or if you are doing any kind of repetitive transformations and if you want help doing that, I will be glad to help you. Of course, it's in Faro, so if you are doing Faro code, then you have to do a lot of stuff repetitively and just contact me. Here's my site. I have the demo on the YouTube channel if you want to do it by yourself, but feel free to contact me.
So I just want to use this time for little things. You are all programmers and we are looking for patterns of programming. So what I mean is that what we would like to do, this is usually when I refactor my code, sometimes I know the next step that I have in mind. You know, for example, if you see in the refactoring browser, when you extract a method, automatically the system will check, oh, there is already a method with this, that is existing in the class, do you want just to call this method instead? This is the kind of things. You have the refactoring, and then the system is looking and said, maybe I can help him to make it a bit better. And we would like to capture this, make it a bit better. So with Gustavo, what we did, I told him, you see, for example, sometimes I just work on one method, and then I know, oh yes, I should check all the other methods in the class, and I should check in the superclass and in the sibling, because I would like to know in the sibling, should I do the same? For example, if I extract a method, I would not like, for example, to return local, but what's happened in the sibling class, and there I have to do it manually to go there and check that. And what I would like to know, this is what are the patterns, and this is very frustrating, this kind of stuff. You see, the last time I was extracting a method in the leaf of a hierarchy, and I have to go all up the hierarchy and check, and you have different routes. So this is just one example. The other example, this is what we mentioned. This is you move a class to a package, and do you keep the subclass in the same package? And in fact, what we would like to have, we would like to have clippy back. So I don't know if some of them remember what Clippy was. This was this ugly word stuff that was trying to help you in a bad way, and the first thing that you did on Windows was to close Clippy because it was so annoying. So we would like to resurrect it to help us for real when we are doing refactoring. So if in your practice you see something that you do and you say, shit, why we use computers and they don't help us for doing that, send a mail to this lab. Okay? So now it's time to
yeah. Someone left these glasses yesterday.
Yes.
Okay.
Thank you very, 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 very much. Thank you. Free case of peanuts for you.
Okay. So this is the end of the Show Us Your project, and we are getting better and better. 8 minutes is very challenging enough. But we will keep it for 8 minutes. Okay. So this year.